Hi dear student, this is Wajid Risha and today we are going to explain or discuss the topic of the verification of the Bohr atomic model based on the Debroglie's concept of the wavelength associated with the electron. Dear students, in 1913, Niels Bohr represented an atomic model in which he represented few points about the atomic structure, the atomic model, the atomic shape and size, etc. The first point of that theory is that mv square divided by r is equal to ke square divided by r square. Dear students, according to this first point, it is stated that the centripetal force which is required for the circular motion of the electron around the nucleus, that centripetal force is coming from the Coulombic force, which is actually the force of attraction between the positive charge of the nucleus and the negative charge of the electron revolving around the nucleus. That is ke square divided by r square. We can write that Coulomb force k q1 q2 divided by r square. So here in this equation we have written q1 is equal to E, q2 is equal to E. So we can put the value of q1 and q2 as E, so we get ke square. So the first point explains that the electron is revolving around the nucleus in a circular orbit having a circular motion, and we know that centripetal force is required for circular motion, so that force is coming from the Coulombic force of attraction between the positive nucleus and the negative charged electron. The second point of the same model was like mvr is equal to nh divided by 2 pi. M is mass of the electron, v is velocity of the electron in an orbit, r is the radius of the orbit, n is the integral number, h is a Planck's constant, already explained in Planck's quantum theory, and 2 pi is constant again. According to the second point, that the angular momentum of the electron revolving around the nucleus should be equal to the integral multiple of h divided by 2 pi. The third point in the Bohr atomic model was delta E is equal to E1 minus E2. The third point in the same model was like in a stationary orbit, electron will have its own energy and it will be orbiting around the nucleus without radiating any energy. So when an electron jumps from one orbit to another orbit, so it will release a photon of energy. And the difference of the energy, the total amount of the energy of the photon will be equal to the difference of the energies of the orbits. This was the third point. So dear students, in this topic, we are actually going to explain and discuss the second postulate of the Bohr atomic model based on the de Broglie's wavelength concept of the electron. De Broglie's proof for the second postulate of the Bohr atomic model. Dear student, as we know that the second postulate is given like mvr is equal to nh divided by 2 pi. So first basically, we will try to explain this equation. What does it mean? So we can modify or simplify the equation like we know that mvr is equal to nh divided by 2 pi, which further gives us an idea that by the cross multiplication we can write 2 pi r is equal to nh divided by mv. We can take mv as a denominator to the right side of the equation, and 2 pi is multiplied with the radius r to the left side of the equation. So we can write 2 pi r is equal to nh divided by mv. R 2 pi r is equal to nh divided by mv. As already derived and discussed in the de Broglie's wave nature of the electron, we know that lambda is equal to h divided by mv. where lambda is the wavelength of the photon or the wave associated with the moving electron, and mv is the momentum of the electron. So we can put lambda instead of h divided by mv in this equation, and finally can write 2 pi r is equal to n lambda. This equation means that from the Debroglie's concept of the wavelength of the particle of a single electron is acting like a photon having a single wavelength lambda. So the experiment for this postulate is that only those orbits are possible for electrons which are having the circumference of the orbit as integral multiple of the wavelength of the electron, which is 2 pi r is equal to n lambda. Now, let us consider the orbit shown in the figure. For example, this is an orbit for the electron, which is having 5 wavelengths here, and obviously 10 number of the loops that represents 5 wavelength. 1, 2, 3, 4, and 5. So we can write this situation mathematically like 5 lambda is equal to 2 pi r, as 2 pi r is the circumference of the whole orbit, and it is having 5 electrons or 5 wavelengths in its orbit. So we can write 5 lambda is equal to 2 pi r. Okay. Now, to explain this orbit on the basis of the stationary waves, which Debroglie actually did for the Bohr postulate. For example, we have a string of length L, and we have connected the string between 2 points A and B. Now we produce stationary waves in the string, so the number of the loops represented or generated is 6, and it represents 3 wavelengths in the total length. So, according to the stationary waves equation, which we had already discussed in class first year, that the total length of the wire should be equal to integral number of the wavelengths, L is equal to n lambda. In this stationary waves diagram, standing waves diagram, the number of loops is 6 and the number of the wavelength is 3. 1, 2, and 3. This is equation 1. Now if we release the same string, the same number of loops from point A and B, and we can make an orbit a circular path from the same number of loops. Here is an orbit which is having number of loops 6 and number of the wavelengths only 3. So the total 2 pi r of the orbit will be equal to the same length of the wire, because the length of the wire is same here and also in this case here. So length of the wire here is here and here is same. Here we have L is equal to n lambda, and for this orbit from this diagram we can have the same length equal to 2 pi r, which is the circumference of the orbit. So from equation 1 and 2, we can have 2 pi r is equal to n lambda. 2 pi r is equal to n lambda, which is verified that time by the Debroglie's concept of the wave nature of the electron revolving in an orbit. Now, there are few limitations of the Bohr atomic model. The first point is successfully explained.